to me, the value of such a project is incredible, is enormous, is really technological advancement becoming an instrument for peace, or at least to maintain the status quo. When things get difficult on Earth, you turn your eyes to something which is happening in space and try to think how goodwill was the moment when this project was conceived.
Hello, everyone. This is the Space Cafe podcast, and I'm Marcus. So, technically, there is no doubt that we have the means, we have the ability as a technological civilization to go back to the moon. There's no question. But are we really ready? And this is the big question that we're discussing today with no other than Giorgio Saccoccia. He's the former president of the Italian Space Agency and the current advisor to the International Astronautical Federation. He is a big shot person in the space industry. He has huge understanding and, in fact, his roots in engineering and propulsion technologies. And of course, this is a topic I didn't want to miss to touch upon because I truly wanted to find out where we stand. Is chemical propulsion truly the only thing to get us from A to B, or is there something else we should be looking into? And alas, we're not only looking into something, but we're already employing new forms of technology to get us from A to B. So without further ado, well, hold on a second. There's one thing I'd like to ask you before we hit it off. If you have the time, my friends, please consider giving this show a rating or a star or two, if you like, on your favorite podcast platform. This is the only language the internet and the algorithms understand, and this would help us propel the show into ever more reach and to get it out, to get the word out there, what it should be. So, and of course, this is an invitation to you. If you want to speak your mind, tell me that something is going wrong, or tell me how great everything is, or you even want to suggest a guest for the show, please send a message to podcast@SpaceWatch.Global. That will be highly appreciated. So, without further ado, welcome Giorgio Saccoccia to the Space Cafe podcast. Let's go. Will we see a human moon landing, human boots on the ground in the next 5 to 10 years?
$100 million question you're asking me. My personal opinion is that we are, as human beings, we are perfectly in condition to establish again boot on the moon in a very short term. It's more a question of priorities, of willingness, and also of educated decisions on what we actually want to do out of that. Because we went to the moon already decades ago, but it was a very short stay. As we all know, it was more intended to be a demonstration of the fact that we could go there, showing superiority, geopolitical superiority. That's obvious. But to me, as a space fan since I was a child, and I remember those moments, even if I was a child, it was also the demonstration when human being, for whatever reason, decide to advance in technology, to really innovate, they're capable to do it in a short term and with extreme success. So we can do it again. We are in the position to do it again. We are working already internationally to do it. When we will reach this moment, it will depend on alignment of geopolitical conditions that, as we all know, are quite in evolution nowadays. So the answer is basically linked to that. I repeat, technologically and readiness-wise, we can do it. We can do it very, very soon.
Where do we stand in terms of technology as opposed to the Apollo years, the Apollo decade today? Is this a completely different generation today when it comes to the available technology to repeat this feat? Or where do we stand?
Absolutely. We are talking about big differences in technologies and in technological approach, and so the way we will use this technology. As I mentioned before, the Apollo project was conceived to have very short stay on the surface of the moon. And it was a quick and fast procurement was part of the whole war, if you want. So starting from the procurement approach, there was a well orchestrated overall design of the Apollo elements, but not so much time was spent on, for example, on interfaces. It's quite iconical in the movie Apollo 13.
Apollo.
But absolutely true. The story of during the emergency, they had to make compatible the use of a air filter developed for the lunar module with the place where it was located in the service module, sorry, in the command module, and they were completely different items. So no time at all was spent to make compatible, to think about for example, serious production. Not at all. There were two separate contractors, but this was saving time because they could avoid any type of interfaces between completely different teams, etc. Nowadays, the approach will be different, has to be different, because of course there is also an issue of economy of scale. There's an issue of sustainability and capability to production of those items for a long term, because the idea is to go back to the moon, to develop a new human outpost there. So this, as a first answer to your question, is something that absolutely already determines a different approach for technology and the technology which is needed. The other subject still linked to that is autonomy in general. The idea is that you explore making sure that you don't need to bring everything with you from Earth. You should be in a position to be as autonomous as possible, to even produce in situ what is needed to build infrastructure, to feed the propellant tank of your engines, even one day maybe to secure and produce what you need for humans to eat and drink. So all this requires technology that at the time were completely neglected. And then, of course, there is a lot which will be linked to the utilization of data, to the analysis and use of the data that will be necessary to not only to be returned to Earth for science, etc., but also to carry out the missions. And on this, we have an incredible capacity with respect to what was the situation in the 60s. We went to the moon with a computer capacity which was not even what we have in a fraction of our mobile phones today. The issue is completely different. So we can do it. We can do it much better, of course, thanks to this incredible technology innovation that we have developed in between. But all this also comes with extra constraints that we need to analyze and put at fruition.
Are we thinking too much these days? I mean, like, it seems like we're dancing around going back to the moon. I mean, like, we've heard this for decades now, that we're ready and we're going in 5 years, we're in 10 years, in 15 years. But where is Artemis at the moment? In the public eye, this is a dance around a topic that is not really clearly understood outside the inner circles. So where do we stand with the Artemis program at the moment? And when are the next key moments? What are the next key moments for the project?
Well, again, of course, my personal analysis of the scenarios is that, again, there are aspects that are of a political nature that, of course, are unpredictable and difficult to discuss about, that will dictate when the next steps of the Artemis program will take place. There are technical aspects that need to be still addressed. We had a very, very successful first Artemis mission that was used to collect a lot of data on the capability of the system to carry out future missions. There were aspects that clearly required new redesign or intervention, technical intervention that have been carried out or that are being worked at the moment, talking about the thermal protection systems, etc. So this is a normal process, if you want, of a classical space project evolution, one step after the other one, of course, because first of all, what is at stake, of course, is the safety of the future astronauts. If I want to compare again with the situation at the time of the Apollo program, for sure there was also at the time, despite of the fact that we are still talking about the same players, institutional players, agencies, etc. At the time, again, the driver was different. Was really a race, and this, in my opinion, was also dictating an acceptability of risks, which maybe today, and I'm happy about that, of course, we wouldn't accept. So so it's not procrastinating, it's not being too cautious. It's simply making sure that that space is safe. Someone could see this as an old-fashioned approach to space. I mean, we've been for years and years thinking about space as something where failure was not an option by definition. Once you send something to space, so far, you cannot intervene on it. If there is a failure, despite of the fact that, of course, more and more over the year, you could intervene and do something, in particular whenever there were software-related aspects. But on the hardware, on aspect where we could not directly intervene, it was impossible to accept risks. Therefore, element of quality and product assurance have been developed specifically for space to make sure that mission, once the public money required to do those missions was invested and transformed into projects, the money were spent and there were no risks associated to whoever, in particular in the human chain involved in the development. Today, space has also a completely different flavor. I'm not talking about human missions, of course, but we have been used to see a more, dynamic approach to space missions, a much higher level of risk acceptability, in particular from the new private players. We see a satellite being launched after very short time since the project was maybe initiated, low level of investment. So it's nice and easy to look at those cases as the new space, the way we should be doing it. Correct, but still, space is not. It's a complex business. It's a rather extreme and innovative field. We have there are some areas where we cannot at all afford the risks. Either you get to this situation simply by trial and error. We've seen this, and we see this with the many new players. Or you do this doing all the possible tests and assessment before launching your item into orbit, which is more the old approach that which demonstrates to be very successful. But again, you need this. You need this in particular when there are human beings involved. So it's important to separate the two things. I hear often, and I'm not happy about that. I hear often making very superficial comments about, I don't know, why we keep on postponing. We need to be very cautious in any case. In particular, I insist when there are human beings involved. And going to the moon, because that's what you're talking about, of course, implies to have a human being, and we need to be absolutely sure that risks that always remain are really reduced to a minimum.
What is the overall vision? I'm asking as a storyteller. What is the main vision to go back to the moon? Because back in the Apollo days, the vision was very clear. It was a very simple race between two superpowers. What is today's vision? And I'm asking this, again, I'm repeating myself as a storyteller, because we know that with a strong vision, engineering and the rest falls into place more easily. So I'm just asking, why are we going back to the moon? Is it just to do it again, or is there a stronger incentive?
First of all, exploration is in the genes of human beings. So, as we discussed, we went, yes, to the moon, but it was like knowing that there is a new region to be explored on Earth, going there once and then, okay, you have done it. That's it. No, there are further steps where you decide to go there. You have opened the path. You want to go there to establish your outposts. You want to understand how to lead there. What can you do there? If there are resources to be exploited, if you can do other things, science, set up a new way of reshaping even a society. I mean, why not? This has happened on Earth and several region. New sociological dynamic. Human beings who live in not easy places are also capable to innovate and to decide how to invent ways to survive and to develop that are then capable to be transferred back to the classical way where human beings live. Living on the moon will mean certainly investing a lot on sustainability, on capability to reduce to a minimum waste and waste of resources, etc. I think would be invaluable what we can learn out of a group of people living and working on the moon that we can transfer back to our old and unfortunately spoiled Earth. So there are an incredible number of reasons that justify this as much as in the history of humanity we have done it for other locations. A lot is said also about using the moon as the starting point for further exploration. For sure, there are elements of truth in it, and will need to be also further explored. So, I would consider as a natural process for human being that you have seen it already in the past, and we will continue to do it forever until we will exist.
Do we, like from a very practical perspective, do we already know when it comes to setting up shop on the moon and finding the energy resources, meaning especially water, where to go? Do we know where the water, the ice pockets are? where we would need to go to in order to be able to refuel and build up habitats, sustainable habitats?
Well, something that happened for sure after the 60s until now about the moon is that we explore it at distance a lot. We know really a lot about the moon. There have been thousands of scientists and missions observing the moon at distance that have provided data that allow us to decide where to go once we decide to establish our settlement there. You mentioned water. Water, of course, is the thing that we look for in a new place by definitions. And for this reason, the south pole of the moon has been identified as the most suitable place to set the first outpost, because there are areas which remain craters that remain always in the dark. So there is high probability to find ice there. Are very interesting also from the scientific point of view, because we can expect that things remain there, maybe unchanged, not modified by sublimation of substances for exposure to the sun, etc., and so on and so forth. I'm not an expert, so what I'm saying is what I read. For sure, there are other areas in the moon that, for example, from a geological point of view, are even more attractive, in particular for the search of possible resources that we can bring back to Earth. We talk about helium-3, as we know, or other elements. But in those areas, there is a lower opportunity to find water. So again, for a human establishment, the preference goes to where we can find water. Going back to technology, going to the south pole of the moon in areas which will be in darkness implies that we cannot count on the utilization of solar energy, which of course has been a new push for the development of nuclear generators that we can use in that area. So again, the target is a reason for technology advancement, and this is fantastic also, because this is the way we innovate and we advance from a technological point of view. We know there are several projects ongoing from this point of view. Whatever we will develop in this sense, we will use back on Earth for other application for sure, or for other element of space exploration in the future.
Observing the current political climate globally and different versions of what we as a humanity want to do and want to pursue, what dreams to pursue, is there a realistic chance that we're skipping Artemis and we're going to Mars instead, because it's the greater adventure? Is there a realistic chance that something like this could happen, that Artemis gets cancelled?
I don't have an answer for that. It's very difficult, because as you said, we are talking about political position, and this is something that change and might change soon. Political aspect implies again a confrontation between blocks, and we are not talking about the same blocks as 60 years ago. There are other, of course, geopolitical blocks, but the interest for the moon and the capability to go to the moon is in the end of each of them, or in the interest of each of them. So what I can expect is that abandoning one target by one of the side might imply that the other one will take advantage of it and will set again foot. So my expectation is that no one will be willing to do it completely, because might be a mistake. If I may make a comment more in general about on the difference with respect to the past. The interesting thing is that today, and despite of the up and down due to changes that we are experiencing actually in those days, the approach is international. for the good or for the bad, but the approach is international. This is the main difference. And there is nothing new under the sun. I like to make reference to something that happened after the Apollo program, when the two blocs, former Soviet Union and US, turned their attention to low Earth orbit. And we had the development of the first orbital stations. They did it initially on their own. I'm talking about the Salyut program from USSR. I'm talking about Skylab, for example, from US, and then the further evolution, Mir from USSR, etc. Initially, they remain as two separate programs, but soon they realized that space is so visible and such an incredible instrument of diplomacy, and this is and will remain always, that it was offering the technology that they had developed in space to other nations was really an advantage. So this Cold War, if you want, was slowly transforming into a diplomatic instrument, sort of a way to attract involvement, initially of like-minded countries. For example, the Salyut program of USSR initially was fully Russians, plus Russia, and in some cases also defense related. Some of the missions of Salyut were of defense nature, defense or offensive nature. And this was a lot related to the fact that the technology initially, so the architecture of those stations was primordial to the point that the missions were unique. I mean, it was the station were launched, they remain, you could do your science or other things, and then that's it. The work was done by the machine. Then the generation evolved, and those orbital modules became open, suitable for expansion, suitable to attract astronauts, cosmonauts, or partners coming, living there and abandoning the station, other coming back, and so on. So those modules and station became an orbital laboratory or an orbital environment where they could not only conduct activities for their own, but also offer them to partners. And again, initially, the partners were partners from politically likewise minded, but then the idea was, no, let's use it to attract other nations to our technological capability. And for example, Salyut initially, but Mir also was later hosting, for example, the European astronaut, as you know, or astronauts from other countries. Same happened from the American side, and naturally, all these developed very naturally towards the fantastic project of the International Space Station, where the station was conceived as an international partnership, not anymore something coming from a block and open to others. To me, the value of such a project is incredible, is enormous, is really technology and technological advancement becoming an instrument for peace, or at least to maintain the status quo of when things get difficult on Earth, you turn your eyes to something which is happening in space and try to think how goodwill was the moment when this project was conceived. I will never forget the moment when I was in Italy as president of the Italian Space Agency at the time, when, of course, the Ukraine war started. Despite of the situation on Earth and the very difficult relation, of course, that had to develop between the different partners of the space station, we still had the station fully operational. And I always like to look at the station as a very unique place in the universe, where astronauts from different countries can move from one module to another one, built in different blocks on Earth. US, Japan, Europe, within Europe, Italy, for example, and they can move without problem of borders continuously during the day, while the overall setup is flying over the different countries on Earth. They speak different languages. Languages are developed and work for a common goal of survival, science, and in particular messages on Earth. It's a fantastic and unique reference, and that's the value of space, and will always be a value of space. Also, going back to the idea of returning to the moon.
This is a beautiful topic you're raising here, and as we're all, I assume, as we're all looking for ways to heal our fractured nations and societies on this planet, is space truly still a peace project? I'm just trying to find if space, like whatever comes after the ISS, if Artemis, maybe even if Mars missions, are these the places where space diplomacy is leading the way for terrestrial fractured diplomacies, where terrestrial diplomacy can learn or can look up to the space diplomacy where things are working? Is this a naive wishful thinking on my end, or how do you see that?
Absolutely not. It's not a naive. Space is something, still today, space is something that instinctively attracts the interest of people. A child, as well as a mature and experienced politicians, for example. I can tell you, I've seen this all my life. It's a fantastic door opener. It brings down the level of the entry level of interest, say. So this is very very interesting and very appealing, I would say, for as an instrument to talk about good things, to talk about peace, to use it as an example for a positive and peaceful evolution of the way we live on Earth. But of course, as every instrument, as every technology, as every tool, you can use it in both ways, because you can use it well. You can use it to do something good. You can use the screwdriver as to fix something, or also to make harm to someone. And of course, space can also be a very powerful weapon, of course. And weapon is has a negative maybe meaning here, but space for defense is again a very positive tool, because the same technology, the same sensors that we have on satellite that we use to make surveillance for emergencies, situations, to intervene in case of disasters, etc. Those same sensors can be used also to spy, for example, to prepare an offensive action, or simply to prevent that an offense will be given to you. The scenario today for a possible attack or offense moves from Earth observed by space to space itself. We talk nowadays a lot, and it will be more and more the case about in-orbit operations, in-orbit servicing. I mean, we want to prolongate the life of our space assets. We want to intervene if there are need for repairs. We need to move their orbit and even the orbit of satellites that are not in condition to do it anymore. We want to deorbit them to avoid to create unwanted space debris. I mean, we need to intervene and have interaction among the space assets. As soon as you have close operations between different assets, you can also use this for offense, of course. All those aspects are part of what we are experiencing today. Is the new aspect of space that so far we could basically almost ignore so far. I mean, already at least until a few years ago, there is not so much regulation. Space is vast. It's difficult to talk about a unique law or regulation to be applied worldwide. So we need to set up also rules, regulation, and ways of looking at space as something where the whole humanity, different countries, not only in collaborations but also in independent setup, operate. We did that on Earth over the history. Now is the moment to transfer this in another domain and dimension. But until we don't, we are not in position to set up a proper approach, a shared approach. It will be easy to mix, or it would be difficult to tell how the use of space activities will be done for peaceful and good purposes, or maybe with the idea to offense. And there will be also there could be misunderstanding, and misunderstanding are very dangerous, or could be very dangerous, as history tells us. When we talk about different geopolitical situations. So it's a moment of evolution, which is fantastic. As you can see, it's not just technology. Technology has and will always have an important part, but space is expanding towards many other fields of interest and responsibility that we have to shape up. And the new generation of space operators has to dedicate a lot of attention to this.
And Giorgio, is the future of space exploration, is this a tandem between the private sector and the national sector, the nation states, the governments, the agencies? Or is it private only because there is perhaps, a different incentive, also lots of funding, a lot more risk-taking? Or is it a tandem in the future when it comes to the big missions meaning going to Mars, setting up a permanent habitat on the moon, going to Venus? What do you think?
I'm absolutely convinced that space is already and will remain for a long time still a mix of private and institutional endeavors. This once again, history teaches us from other fields. If you think today, even for commercial flights, airplanes, It's true that it's mainly privately driven, but there is a lot which is still supported by government regulations. We will experience maybe a shift of responsibilities, a shift of the initiatives. But what we see today is that institutions, agencies, government are supporting a lot a flourishing of the private sector, because this, of course, as I said, is generating economy, wealth, is an incredible opportunity. But at the same time, we are very cautious in controlling that this will not happen in a wild way to avoid what I was mentioning before, of course, because still is a completely green area. So certainly a tandem with an evolving shape, and I'm sure will remain for a long time. I hardly believe that we will experience before decades a situation where only space will only be private.
Giorgio, I'd like to go to a topic that forms the basis of your incredible career, and that is propulsion technology, engineering in propulsion technologies. Going into space is a long and tedious endeavor, especially going from A to B. That sounds banal, but it's not. To go to different places. I mean, like even going to Mars is a month-long endeavor, just one direction. And I'm not even talking about other celestial bodies. So I'm just wondering in how far propulsion technology is holding something essentially new for us at some point in the future that will help us shorten that travel time. Or I'd love to learn a lot more about propulsion technology, from where it comes from and where we are headed to, and maybe find out a little bit what is being developed at the moment.
Okay, well, with pleasure. Propulsion is a fascinating field because it's very simple. It's very elementary, the concept of propulsion, space propulsion in particular, because it all goes down to ejecting a certain mass of propellant at a certain speed. The higher the speed or the higher the mass, the higher is the change of motion that you can apply to your spacecraft or to a rocket that is leaving from Earth, etc. It is simple, as I said. The problem is that you need a way to accelerate this propellant, and you need the propellant itself, which is heavy, and mass to carry with you is the opposite of what you want to do for in space activities, because mass means cost. It means even not being capable to carry out a mission because your satellite will be too heavy or your rocket will be too heavy. So the whole effort in propulsion since the conception of the first concept of propulsion is meant to increase this product of mass and velocity, or at least to act to reduce mass or to increase velocity. And there are a lot of technologies that are there to propel our spacecraft or our rockets that can be adopted and used depending on the application. Why I say this? Okay, for rockets, certainly you need trust. You need a lot of trust in short term to be able to leave Earth and Earth gravity. So what we experience today, I mean, the rocket propulsion for rockets is quite advanced. The main effort today is more intended to reduce costs, to make sure that you can have a large production of those rockets, because rockets are I would say the first space item where you are interested in economy of scale. It's very interesting. I really adore to see, for example, the evolution of the engines developed by SpaceX. First, second, and third generation is a marvel of a simplification, and which means cost reduction. That's of course still keeping as much as possible reliability. On the other hand, they are also investing in the use of several engines on the same rocket in such a way that you have an intrinsic redundancy on the way you operate your missile. But again, the technology is always the same as a concept. Different is when you move to space, to satellites, because they're moving from A to B in space. The concept is again the same, but you can do it in different ways, and with different purposes. You can, again, be interested in having a quick transfer from one orbit to another one, from one orbital position to another one. And maybe you can afford to waste a bit more propellant than using other technologies. Or you can afford to, initially at least, to move slowly, slower than using other type of propulsion, but you will save an enormous amount of propellant. You will prolongate your mission, or you will reach destination that with classical propulsion will not be possible. This is the case, for example, of electric propulsion, which is a field where I've been exposed a lot, in particular, actually from the very beginning of my career. And electric propulsion is a fascinating field because the difference with classical propulsion is that the energy that you use to accelerate your propellant is not intrinsically embedded in your in the chemical bonding of the propellant you use, but you take it from outside, from an electrical power source.
Can you give us an example how electrical propulsion works?
Yeah. For example, I take one type of technology, the so-called grid ion engines. But these apply also to other technologies. Basically, what you do, you use as a propellant, contrary to the classical hypergolic or very, very highly reactive propellant that are used for chemical propulsion, you use a noble gas, xenon, argon, for example. Why use those gases? Because those gases have as a property the capability to ionize easily. Ionize means that you can separate the electrons from the ions in the nucleus. And why you want to do this? Because then the ions will have a charge, positive charge, and with certain devices in front of those plasma, at that point plasma is a coexistence of ions and electrons, but separate and not together. If you put in front of those plasma a negative charge enough to voltage enough intense, you can accelerate these positive ions and make them leaving the engine, leaving the satellite, and create this famous mass times velocity that you're looking for. Now, what is interesting about electric propulsion is that, contrary to the classical chemical propulsion, the velocity is incredibly higher than the chemical propulsion system. Can be 1, 2, 3 order of magnitude higher, which means that you can obtain the same change of velocity by reaction on your satellite with much less propellant. The classical, the main difference is that the thrust you apply is typically much lower. I mean, you can not use electric propulsion to take off a rocket from Earth, because you need tons of thrust. But you can gently keep on pushing your satellite for days, months. And this means that your satellite will keep on accelerating slowly initially, but then more and more. Eventually, you can reach velocities that are much higher than the one you will obtain with a classical big push with chemical propulsion.
So that would be a little comparable, although a completely different technology, but the one with the solar sails that's being propelled through lasers.
Solar cells is even another concept, because for solar cells, the push is applied from outside. Is a light pressure that is pushing, indeed a sail or electric sail. So you don't have propellant on board. That's a propellant-less concept. Electric propulsion still has propellant, but it uses much less, which means that there would be missions that with chemical propulsion you cannot do because you don't have enough capacity in your tanks, in your mass, that becomes feasible. A classical example is BepiColombo, the mission to the planet Mercury. BepiColombo without electric propulsion would have not been feasible. With electric propulsion on board ion engines and a certain number of flybys, has become feasible in terms of payload that is being brought. Another example I like to use, because you've been talking about the moon and it's very close to my heart, is the Smart 1 mission of ESA. Smart 1 was a technology demonstrator satellite, which was launched in 2003. It was the first European mission where we have used electric propulsion for design to do the orbit transfer from Earth to Moon. From Earth, I mean from the geostationary transfer orbit. Smart 1 was a small satellite, about a cube of 1 meter of base, and 300 kilograms, if I remember well, something like that. So a relatively small satellite meant to do technology demonstration, electric propulsion, and some science observation around the moon. Was a cheap mission, so we could not and we didn't want to afford a dedicated launch. So it was launched on Ariane 5 as a not even secondary but third payload. There were 3 satellites on that mission. The third one was Smart 1. The first 2 satellites were telecom satellites. So the orbit where Smart 1 was delivered was the one of the main payloads, which was a geostationary transfer orbit. The worst orbit you can imagine if you want to go to the moon. You prefer to start with different type of orbit. So from there to the moon, Smart 1 used electric propulsion, so-called Hall effect thruster, to perform a slow transfer that lasted almost 1 year, eventually getting around the moon and entering a moon orbit and conducting for 1.5 years science there. To do all this, it consumed, if I recall well, I think 65 kilograms of propellant.
Interesting.
Once I made a funny, calculation, because of course all this was done during the orbital revolution, etc. I made a funny calculation because, of course, it's not the type of calculation you want to do, but I evaluated that it was, Smart 1 was consuming something like 1 liter of propellant per 2 million kilometers. It would have been a perfect performance for a governor. But it's just to say that is a completely different way to look at future missions. Imagine that using electric propulsion, you can have, orbital tag that might take a main payload, bring it to Mars, and coming back to get another one. You can reshape the way you conduct space exploration with the use of such a technology. For sure, it's already extremely successful for the application to commercial telecom mission, etc., because it has allowed a complete redesign of the architecture of those satellites in terms of mass of propellant that those satellites have to embark, volume of the tanks of this propellant as well. You can imagine, you don't need, just to give you an idea, before propulsion was introduced, a large commercial geostationary satellite, a big beast in the order of 5 tons at launch, half of it was propellant, something that you were just wasting. Using electric propulsion, you could reduce this amount to, 500-600 kilograms. So saving up to 2 tons of not used mass that could be translated into different things, like more transponders, so making more economically viable an investment to develop a satellite like this, or embarking more propellant to extend the life beyond a certain duration, so continues to give revenues to the users, to the investors and service to the users, or simply doing a smaller satellite and making use of smaller rockets. That today maybe this is less attractive than in the past, but when you move back 10 or 15 years ago, using a smaller rocket had as an impact a much lower initial investment. So I need a quicker and faster return on investment for the investor. So the adoption of electric propulsion was having this type of implications.
So I could think from my very lay perspective here, I could think of a combined solution for interplanetary missions. So whenever you need to overcome gravity, you will need chemical. So if you want to leave a planet, if you want to land on a planet, you will need chemical. But for the transfer in between and for the correction maneuvers, this would be electrical. Is there anything that speaks for chemical during transfer, or would that combination I just sketched out make sense?
No, you are perfectly right. It's exactly the type of scenario that we are envisaging today. The only thing that, not the only, but certainly something which will be very in favor of still of chemicals for the transfer, it depends on from where to where you want to go, because for certain distances, the chemical transfer would be still quicker. And in particular, if you're talking about human missions, you want to reduce the time of transfer for the astronauts. So it really depends from where to where you want to go. On the energy you can embark, because of course you can increase the thrust of electric propulsion, but you need more power, more energy. So we are limited today by the solar panels, but maybe one day with nuclear propulsion, nuclear energy on board, we can afford bigger electric propulsion engines. So there will be evolution in this sense, but certainly thrust, which is the characteristic of chemical propulsion, is still on their side.
Is this already being looked into when it comes to our next big leap? I mean, like for the moon, I don't know. I would love to hear from your end what makes sense, how to go to the moon. But then maybe when we go to Mars, I think to the moon it's just 3 days, but to Mars it's a couple of months. So is it being looked into as to use, or if it makes sense to use electrical over chemical, or where do we stand here?
There are plenty of studies. There have been also in the past plenty of studies on different architectures, including to the moon, even if it is so close, say. For sure, the use of electric propulsion for cargo mission. I mean, you don't just go to a place with a human. Going back to our discussion before, the idea is to go there to stay. So you will need supply, you will need infrastructure, you will need many things that you still will have to bring from Earth or from wherever you will be living for the next step. So for those things, the use of electric propulsion will be essential, will be absolutely a must. items, infrastructure, modules, cargo might be sent in advance, giving enough time to electric propulsion to reach the destination. And then when everything is ready or will be assembled robotically or by other exploratory human missions, you will send possibly as fast as possible your humans to utilize this infrastructure and those supplies. So yes, as usual when we talk about space, rationalization and planning will be really the winning element.
Mm-hmm. A very mundane question to you. You're from Italy, and wherever I go, when it comes to space topics, whenever I engage with ESA and other places, Italians are everywhere. Is Italy a superpower in space?
Italy is a country with a very long tradition in space, and has been one of the first countries to send satellites into space. Is high, has been always high in the agenda, also in the political agenda, visible, very visible. So there is also an element of pride linked to that. In the field, it's one of the few countries in the world. There are more of course, but one of the few countries in Europe and in the world that is dealing with all the aspects of space activities, all the type of applications, from rockets to Earth observation, telecom, exploration. And this is certainly a plus and advantage because it gives the opportunity to really look at all the opportunity and also to cross-fertilization. If you take, for example, the subject of today's discussion, we are having exploration. Italy has a very privileged position there because since the beginning of the European involvement in exploration, Italy has a dual corridor. Is working, of course, very actively with ESA through the different ESA programs, but it has also conducts also development and projects in bilateral with nationally with other countries, in particular US so far. What I really like of the exploration exposure of Italy is that it has been a very good case where institutional investment coming from the government and deployed through ESA or nationally have generated a capability that has educated eventually also private commercial capacity, say. To give an example, you take the investment done for the to develop the pressurized module first of SpaceLab, so application on shuttle, then the space station. Space station, there we have had contribution to the European modules, Columbus, but also pressurized modules that have been developed directly by the Italian Space Agency and offered to the partners of the space station. The expertise, the competence developed by Italian industry for that has allowed them, independently by any government influence, has allowed the Italian industry to continue to offer similar modules, or in any case, supply modules developed on the basis of this competence to American partners, commercial partners. And for example, in this way, the Cygnus supply module has been developed with a very strong contribution from Italian industry. This concept for the space station, for low Earth orbit, is being transferred also to the moon in a way, because we have a similar situation there. For the lunar gateway, the Italian industry is contributing significantly to the high-hab European module. At the same time, they are working on a direct contribution to the gateway. And I'm aware of the fact, it was initiated when I was there, but they are continuing, that there are also discussions ongoing to contribute nationally to first element on the surface of the moon, first multipurpose application and elements, as well as, of course, working still with in parallel with ESA on concept like the European lunar lander, etc. All these again will generate and will reinforce the capacity of Italian industry to operate on their own commercially. And I think this is exactly the way I see, and I see more and more for the future, the synergetic way of operating of institutions and private sector to really develop the future space economy.
With Italy being a very strong player in a community, being the European Union, where do you see the European Union in the international game when it comes to making humans an interplanetary species, making baby steps at the moment, getting our hardware ready? Where do we stand as Europeans? What's our niche, and what are our strengths and weaknesses?
Well, the European Union adds at European level the political element, which is necessary. We have been already extremely successful through the European Union in developing projects like programs like Copernicus, like Galileo, and we have been able to do this thanks to a political decision as European that has eventually set the scene to develop fantastic machines that are used for the benefit of all European citizens. ESA has had this essential role of enabling technically this vision, this dream. European industry has played this role, of course, to put it into act. I think when Europe wants to operate together with a clear vision, we are very, very successful, and we can be very successful. I don't see why we shouldn't be also in the future. There are new ideas, new projects in the making, RA2 for communication, secure communication. Others might come in the future. We are a continent with a lot of people, with tradition and with a natural capacity for innovation. We have no reason and no constraints to continue to leverage on that for the future. I'm profoundly convinced about that. So it's just a question of willingness and understanding also what is important and where the priority is for us for the future.
If we take a look into the future, 2040, the next generation of space leaders, what is the one skill or area of expertise we might be overlooking at the moment, and which are essential for next generations of space leaders?
Always the same: curiosity and passion. This is the driver for the next steps.
Giorgio, if the call came, would you board a spacecraft, and go to places like the moon or further?
Well, this is, of course, part of my child dream, and we remain children with our dreams for all our life. So why not? I cannot exclude it.
We have a fun tradition here in the Space Cafe podcast. I initiated a playlist on Spotify. It's called the Playlist for the Aspiring Space Traveler. And I ask each guest to contribute one of their favorite musical pieces, which they would not want to miss on their personal trip to the planets. So just imagine you're going to Mars, you're going to Venus, and things get really boring. What's the one piece of music you would not want to miss?
Well, I I mean, I'm an old guy. I'm a fan, of course, of the music from the 70s, etc. I like groups like Pink Floyd, etc. I think when I think, and also in the past, when I think about myself floating in space in a mission, the type of music of Pink Floyd is ideal to set the background, in my view. So yes, I would use. So I always choose something from the dark side of the moon.
Which one? Which one should I put on the playlist?
Maybe if I remember well, the title of the final one is Eclipse of the Moon, something like this. Now I don't remember the titles, but that would be very nice, very relaxing.
You know, I'll look it up and I'll take the last piece from the album, okay? Last question, Giorgio. As an Italian, you being an Italian, you are leading not only many aspects in the space industry, but also in coffee culture as an Italian. This place here is the Space Cafe podcast. Now and then you go to coffee places to energize yourself, to have a strong shot of coffee to energize your body. I challenge you now to share an espresso, a strong shot of coffee for the mind with me and the audience. What's the one shot of inspiration you would like to share?
Well, I'm a person of compromises when they're needed. That's why I always I ask for a macchiato. And I think you don't have to have strong position. You have to be always open to different flavors. That's why I think macchiato is a good combination for me, because coffee can be very bitter, in some other cases too sweet. So it smooths down and makes the beverage more appealing to me. And this is, I think, is what happened. Whatever I do, in a way, I'm always open to influence that could modify the sharp corners of a certain position we have. So I will go for that.
Wonderful. Giorgio Saccoccia, thank you so much for taking the time.
It was really my pleasure.
And that brings us to the end of another show with the fantastic Giorgio Saccoccia. Thank you so much for taking the time and for sharing your wisdom. By the way, I picked the last tune. I looked it up. I had to look it up. And the last tune on that Pink Floyd album is Eclipse. So be it. It's already on the playlist. By the way, my friends, have you ever checked out that playlist? It's on Spotify. If you look for the playlist, let me just check the exact title. Hold on a second. So it's called, hold on. It's called the Aspiring Astronauts Playlist. I kept labeling it completely wrong all the time. So here is the official title. It's the Aspiring Astronauts Playlist. And currently we have, almost 100 tunes on it. And you should check it out. Perhaps if you go into space, if you're traveling to Mars or the moon or wherever, this may be the place that other guests from the Space Cafe podcast would enjoy on their galactic ride. Yeah, so if you find what we're doing here is interesting, consider sharing it with a friend. Consider sharing it with your kids, because they're the next generation of space leaders, and perhaps they're taking something out of it, or you're just talking or sharing it, whatever you feel like is interesting from that show, with someone you like. And perhaps leave us a rating or a review on some of those platforms out there. So Other than that, there's nothing more to say. Thank you so much for your valuable time, my friends. This is highly appreciated from the bottom of my heart. And I'm looking forward to seeing you in 2 weeks from now. Bye-bye.